Yes, this is Aisha, I hope. Aisha and Terim, right?
Yes, ma'am.
Okay, Aisha, you can mute yourself. So in the last class, we had started with collision and collision, elastic collision, inelastic collision. Main topics we had completed. So a quick revision of it. So in case of collision, we had seen that collision is what? It's an isolated event in which what happens? In which a force acts on a body for a very short duration of time, and we call that as impulsive force, right? This results in change in their velocity. So whatever is the initial velocities, that does not remain. You have final velocities later on. Then two types of collision we had seen. One was elastic collision, other one was inelastic collision. Right? This is inelastic collision and this is elastic collision. Now, elastic collision and inelastic collision, we had discussed the major differences between them. So in case of elastic collision, we had seen conservative forces apply over here. And in case of inelastic collision, we have non-conservative forces. Non-conservative forces depend on the path traveled. This is independent of the path traveled. This just depends on the initial and final points. Then there is no loss of energy in case of elastic collision. There is a loss of energy in the form of heat and sound in case of elastic collision. And one thing that remains, that does not remain conserved in case of inelastic collision is the kinetic energy. This quantity kinetic energy does not remain conserved. Then coefficient of restitution we had seen. In case of coefficient of restitution, it was the relative velocity that was initially before collision and relative velocity after collision. After separation is the name given and relative velocity of approach is the name given before it. So this is known as coefficient of restitution. So coefficient of restitution, we had derived it. Coefficient of restitution, we had derived it for elastic collision, and this was proven that E is equal to 1. And V1 and V2 basic formula, I have also discussed this with you. We did a question also based on this. Now see, before we begin with inelastic collision, no, here you have special cases also that you have to remember. Special cases. Now see, in special cases, two cases we'll see that if somehow both the mass of the bodies become equal. Why are we doing this separately? We are doing this separately so as to have an idea or to get a final formula. Now what will happen? If we know this, then you don't need to derive it in the exam. Now see, this is M1 is equal to M2, which is equal to M, let's say. Now let's see what will be V1. See, V1 will be what? Formula is M1 minus M2 into U1 plus 2M2U2 by M1 plus M2. So this is same. It means this part will get cancelled because this is now equal to 1, this single M, right? So this is now since equal to this single M. So this is M1 minus M2, that is U1, fine, plus 2M2 into U2. Now see class, if this is the case, then what is left over here? This whole entire term becomes 0. We are just left with 2M2U2 divided by, now see, M1 plus M2. I can write it as M2 plus M2 because both are same. That makes it 2M2 again. So 2M2 gets cancelled. V1 is equal to U2. What is happening? The final velocity of first body becomes the initial velocity of second body. And similarly, same thing will occur. Similarly, V2 will be equal to U1. It means final velocity of the second body, this will be equal to the initial velocity of the first body. It means velocities get interchanged. This is like this. M mass is there, U1 is there. This is M mass, U2. Remember, we are not using M1 and M2 because both the masses are same. So we are using single term only. Now C class. U1, U2. Now see, after collision, no, what will happen? Once collision has been done, when collision is over. Now this is M, this is M, this becomes U2, this becomes U1. It means velocities get interchanged. V1 is now U2 and V2 is now U1. So their velocities have actually exchanged after the first case. So let's say this was 10 meter per second, this was 20 meter per second. After collision, this will be 20 meter per second and this will become 10 meter per second. Like this will be the difference that will arise. Fine, this is the first case. Second case, do one thing. Note down the first case, then I'll discuss the second case with you. So who all have joined? Aisha, Jania, Abdullah, Tehreem, and Waziha. Okay. All right, class, let's come to the second case. First case, I think it's clear. The velocities simply get interchanged. Now, see, coming to the second special case. See, in case of second case, if M2 is very, very greater than M1, it means first body is very small and the second body is comparatively greater than it. So what happens here? You will have the initial velocity as u1. Fine. Here you will be having the initial velocity as u1. But the initial velocity of the second body that is present, that the second body's initial velocity will be 0. Why? See, reason is that the body M2 is so huge that the velocities will not be even considerable. Like this is M1, this is M2. So velocity for this U2, this will almost be 0. That is the case over here. So that's how you can reduce your answers, right? U1, why? Because M2 is very huge in comparison to M1. So whatever is the velocity, no initial velocity, that gets neglected in front of it. So U1 is there, U1, but U1 if you compare U1 and M1, let's say U1 is 5 meter per second, M1 is 5 kg. So comparable. U2 is 6 meter per second, M2 is 1000 kg. So will there be any motion that you will be able to observe? If M2 is so huge, the velocity will be so less that you will feel that the body is stagnant. Fine. So in the formula, V1 is equal to U1 M1 minus M2 by M1 plus M2 plus 2 M2 U2 by M1 plus M2. In this part, see, U2 is 0. So this entire term will become 0. Now, whatever terms are left, this can also be simplified. How? See, M1 minus M2. This will be almost equal to what? Almost equal to M2, no? Minus M2 only. This part only. It will be almost equal to M2. You're subtracting a very small number. It's like if you subtract 1 from 1000, what is left? 999. So you can say 999, or even you can write it as 1000 only. No need to reciprocate it even. So same thing here. It's like you're subtracting from a very, very huge number, you're subtracting a very smaller number. So though it should be minus M2, but definitely masses magnitude can never be negative. That's why we are writing it M2. Otherwise, this has to be written as minus M2. Fine. Now, C class. Also, M1 plus M2, when we write this, M1 plus M2. This is almost equal to M2 only. Reason? You're adding a very small number to a very huge number. Like in 1000, you're adding 1. So 1001 you write, or even if you write 1000, that is almost equal. So that's why we are writing M2 only here. So if you write M2, V1 will become what? U1. This entire term becomes M2. This entire term becomes M2. Cancels. So V1 is equal to minus U1. Actually, you should write, because this is minus. So let's write minus, because this is minus, this sign. All right. And what else? Similarly for the second one. Now see, for the second velocity, when we'll write this, this is the first velocity. It means now what conclusion can you drop out from this? Conclusion that you can draw is initial velocity and the final velocity's magnitude become equal. Whatever is the magnitude, both become equal. Fine. This is what is the conclusion that you can drop out from it. Also, same thing will occur in case of the second. V2 will always remain 0. V2 will remain 0. Why V2 will remain 0? Because it's like a big wall is there. You can take the example wall, and on this big wall, a very, very small ball has collided. Very small. So it's like what? If a huge wall is there and a small ball is colliding. So what is the final velocity of wall? Will there be any motion in the wall? The wall will be at its place because the small ball will not do any harm to the ball. If the masses were equal, let's say two balls are colliding, then they can hit. But if in a big wall you are hitting a very small ball, a very light tennis balls that you have, or very light balls that you have, so what will happen? There won't be an effect on the wall even after collision. So final velocity of wall will be zero. Same thing is here. That's why the final velocity is zero. And the last case. Now, very less topic is left. This chapter will be completed today. Then you have your test on circular motion. Vazi, I think you were confirming the syllabus, no? I hope you received it. You received it? Okay. Case 3 that we have is opposite. If M1 becomes greater than M2, it means the first body's mass is greater. So this is greater, this is M2, this is U2. Now same thing, what will happen? This term will become 0, right? This is M2. So now V1 will be equal to U1. And if you'll write it, if you draw everything in the same formula, you will obtain here that the final velocity is twice of that initial velocity just because of calculations in the formula. Fine, same thing will occur. And no need to even go into the details. This is just some extra. You can do it as a homework to prove this. This will be the final answer. Fine, note these two cases and we'll do inelastic collision. Inelastic collision is very small, and then elastic collision head-on, that oblique one is left. No, this was head-on, oblique collision is still left. That has to be done. So that we'll do, just note down this second case. Second case, that's why I've done it in detail so that you will be able to analyze all the next cases. See, in case of inelastic collision in 1D, no, we'll apply same conservation of momentum. So momentum's formula is mass into velocity, right? So same thing we'll apply, conservation of momentum. See, this is the initial momentum, m1u1 plus m2u2. And final momentum will be m1v1 plus m2v2. Now see, perfectly inelastic collision means, yesterday I mentioned you that both the bodies stick together even after this occurs. Yes, class. Now see, perfectly in case of perfectly inelastic collision, what will happen? M1u1, M2u2. Now both the bodies stick to each other and do not get separated. That collision is known as perfectly inelastic collision. So both will have a common velocity v, right? Now apply conservation of momentum. Again, this was initial conservation of momentum. Now when you apply conservation of momentum, that becomes m1u1 plus m2u2 is equal to m1 capital V plus m2 capital V, because it's the common common final velocity. So take final velocity as common. That means m1 plus m2 into capital V. So what is the common common final velocity? m1 u1 plus m2 u2 divided by m1 plus m2. Fine, this is the final velocity that is present. So this is known as common velocity, common final velocity, common final velocity with which both the bodies are moving. Fine. So loss of kinetic energy, if you want to calculate, same thing. Loss of kinetic energy, that will be same the way we had calculated it for the elastic collision. Whatever is the kinetic energy, initial minus kinetic energy, final. Now, why not final minus initial? We wrote it as initial minus final because this is loss in kinetic energy. This is the loss in kinetic energy. Right? Energy is not conserved. Kinetic energy is not conserved in case of an elastic collision. So here what is happening? There's a loss. So your answer will come in negative. That's why we wrote it as KEI minus KEF. Means initial minus final. Definitely final will be greater. So you'll get your answer in negative. And that negative sign will only show you that yes, there's a loss in kinetic energy. I'll show you. Let's take an example over here. One example, let's take one question in the form of question. Let's do this. One body is there having mass 2 kg, moving with 5 meter per second. This is 3 kgs moving with 2 meter per second. And they have a head-on collision. And they stick to each other. So which type of collision is this? Yes, can you name this type of collision? Elastic, inelastic, perfectly inelastic, perfectly elastic. What type of collision do you think this is? Yes? Yes, class. What is the answer to this? What type of collision is this? Aisha? Aram? Yes, Aisha, you were trying this? If you all do not know what type of collision is this, then how will you answer it? How will you use the formula? Which formula will you use then? Jania? Waziha? Which type of collision is this? Elastic, perfectly inelastic, elastic.
Perfectly inelastic.
Perfectly inelastic. Very good, Waziha. So only Waziha knew the answer. What about others? Aisha, Aram, whoever I had called the name. Just now, no, we had discussed this. That two bodies are moving with independent velocities. How to identify that this is perfectly inelastic and not simple inelastic? By just looking at that, both the bodies are having final common velocities. Is it clear now how to identify? Yes or no? Clear or not? Aram, Aisha, clear to you?
Yes, ma'am.
So please respond in the class. Otherwise, this will become very difficult. Then I'll ask you all to open up your videos. Then only this your answers and interaction will be possible. Whatever, at least if you are unable to unmute yourself, then try to write in the chat box. Even that I allow. Write in the chat box, I'll read it, whatever you want to answer or whatever you want to say. Even if you want to write, I don't know. So this is perfectly inelastic. Now final velocities formula was m1u1 plus m2u2 by m1 plus m2. So final velocity will be 2 into 5 plus 3 into 2 by total mass is what? 3 plus 2. So this becomes 10, 10 plus 6, 16, 16 by 5 meter per second. What I wanted to tell you was the loss in kinetic energy. So even if you calculate the loss of kinetic energy, no, so that will be initial kinetic energy minus final kinetic energy. That's what we did. So initial kinetic energy is half m1, that is 2 v1 square, that is initial velocity, that is 5 square, plus this is still not the initial, half mv square, or you can say half mu1 square. Basically this is half mu1 square plus half mu2 square. This is the total initial kinetic energy. Final kinetic energy, half mass is 2, but final velocity, we can take this common. Total mass becomes 5, and we can take final velocity 16 by 5. So this is half 5 into 16 by 5 whole square. This is your answer. 2 gets cancelled. The square gets cancelled. This becomes 25 plus 3 into, this is 25 plus 6, right? This is 25. This is 6. 2 into 3 is 6 minus. See, 1 square will cancel this. That becomes 16 square by 10. So this should be here. You'll get your answer in negative. See, 25 plus 6. Definitely, 25 plus 6 is a very smaller number. If you see this in comparison, even directly, even if you write it from 16 by 5, right? 16 is there already. So 25, when you will use this 25 plus 6, you will get it as 31. Now see, directly, even if you use this, 16 into 16 is 256. So by even looking from here, this is 31 minus this becomes 256 by 10. No, 10 will be leaving. No, this is coming positive, then that becomes 25.6. Five square is there, 16 square. So total mass was 2 plus 3, 256. This final velocity is 16 by 5 whole square, right? So that makes it 5's whole square as well as 16 whole square. So there should be a loss in kinetic energy. Here, I think because I have taken the random data, no, that's why this is coming out to be positive. Otherwise, if proper data and proper question is given to you, then you'll get your answer in negative only. Right now, I had taken random values that must not be matching the perfectly inelastic collision one. Since I have taken random values, that's why this is coming out to be positive. Otherwise, this will come out to be negative only whenever you have it in case of perfectly inelastic. That's why I think no need to write it till the last step. Till here only you can leave it and remember in mind that you have to take it as negative, or the answer will automatically come as negative. And this is how you use the final velocities formula for perfectly inelastic. Quickly note it down, then we'll do that in elastic collision in 2D that was left. That was your oblique collision. So from here you have to write inelastic collision. See class, in case of elastic collision in 2D, now this part that is present over here, this part that you have, M1 and M2, their final velocities, it will move obliquely. This is V1. This is V2. Let's say this is making some angle theta. Now this is also nothing new in here, nothing difficult in here, because you'll just perform resolution of vectors. So this becomes V1 cos theta. For this becomes V2 cos theta. Here, this will become V1 sine theta. Here you will obtain V2 sine theta. Like this, same thing. Fine. Here, all the things apart from this remain the same. Now you will apply same thing, conservation of momentum along x-axis. Now you'll apply conservation of momentum along y-axis. That's what the difference just that will arise. Fine. So conservation of momentum. So along x-axis, if you have, see, along x-axis, we'll be considering just the cos theta component. So initially this will be there. That is M1 U1 plus M2 U2. This will be there. But finally, this will be M1 into V1 cos theta. Not theta 1, 2. Let's take it as theta 1, 2, because we are not sure whether it is same or not. Plus M2 V2 cos theta 2. Like this. This is conservation of momentum along x-axis. Conservation of momentum along y-axis. See, there is no initial momentum along y-axis. So this initial momentum will be 0. And what about the final momentum? This will become mv1 sine theta 1 minus mv2 sine theta 2. Not m1, m2. Why minus? Because upwards positive, lower negative. You have to apply the sign conventions as well. So that's why this is negative. Now you can write m1 v1 sine theta 1 is equal to m2 v2 sine theta 2. You can use these equations as well, even if it is required in your answers to solve. Also, you can apply conservation of kinetic energy here. Fine, because this is elastic collision. So kinetic energy, this will be conserved. So it means half m1 u1 square plus half m2 u2 square is there. Now for kinetic energy is a scalar quantity. So whatever was the final velocity, just put it as it is. No need to resolve it. Why did we resolve it in the above case? Because your velocity's value was different. We had to resolve it because it was making angle for momentum. Right? Momentum is your momentum, linear momentum that we are writing. Here, kinetic energy is completely scalar quantity. Just use V1 and V2. So that becomes half M1 V1 square plus half M2 V2 square. Like this. This is only about elastic collision in 2D. Quickly note it down. From here. No? Now see class, in today's assignment, you will get questions on this only, elastic collision in 2D. So practice the question, send me your assignment and I'll discuss it on the next class. That is your Monday. Yes, Monday I'll discuss it. Also backup timings I have to discuss with all of you. Who all are there? I think Tareem, Waziha, Jania and Aisha. You all will be needing the backup classes, no? We'll have the backup classes on this Friday. Firstly, we'll have this on Friday, first class. Yes, Aisha? Yes, this Friday. Just extra class for all those who have missed this. I'll tell you the topic and that can be discussed. All right. So in this Friday's class, now we'll discuss just the basics. Calculus we'll cover this Friday. Calculus we'll start with, because without this you'll not be able to understand it. Fine. So calculus we'll try to do, that is your differentiation and your integration basics we'll do. See, IST same timing 7:30. This is IST timing, 1 hour class only I'll take, because we just have to do the backup brushing, and video lectures also I'll send you. So rest of the things you can tally from the video lecture. So 7:30 IST means that is 5 p.m. for you, no? So 5 p.m. KSA timings. So this is for Friday, this Friday. So all those who want to join, you can attend. If you are well versed with calculus, no need to attend this. Yes, class completed.
Yes, ma'am.
All right, and let's start with your test then. you all can start your paper. And on WhatsApp, you all have to upload the PDF of it. Fine. So I hope all of you are added on the group. Those who are not added, I'll share your number. I'll share my number with you all. So 3 questions are there. Direct questions are there, which we have discussed. Start with it, class. I'll share my number in the chat box though, for those who do not have my number. And yes, all the students who were not present, if someone is having difficulty in it, so like Tareem and Jania, I think, and Aisha, you didn't attend the class of it. So if you are comfortable, you can give the test. Otherwise, take the screenshot of the sheet and send me as an assignment later on. So I've shared my number also in the chat box. So I've given the liberty to the students who didn't attend it, who didn't attend the class. Rest of you, you all have to open up your cameras and answer it because focus mode is on. So now all those students, your video will not get recorded. Nothing will happen. Only I'll be able to see you. So yes, Abdullah, Aram, all of you, please, if you want your paper to be considered, please open up your video cameras and then answer. So only 1 or 2 students have opened up their cameras. Rest of you also, Aisha, Aram, Abdullah has opened. Waziha, you, all of you, please. No, Terim, you can leave. If you've taken the screenshot, no, just take the screenshot so that you have the paper with you. You can leave because now after this, the class will be over. Half an hour time is there. On Friday, join the class. And then after it, simply on Monday, I'll start with a new chapter. So from the new chapter, all the students will be able to understand, hopefully.
Okay, ma'am. Thank you.
Same goes with others also. And yes, so only Waziha and Abdullah are giving the test right now. Last 10 minutes left. Hurry up, class. Okay, Abdullah, just send me it. If you've submitted, just send me and then you can leave. Wazia, you also hurry up. Only 5 minutes are left.